Good morning and good evening, everyone. Welcome to Salesforce Apex Hour. So, as promised, we are again come back for the new topic and with new speaker. So today the agenda is the big object. So how to set up the big object and what is the advantage of that. So that we are going to discuss today. And today Jigar will be going to present that. So Jigar, can you move to the next slide, please?
Sure.
So let me give you my introduction. My name is Amit Chaudhary. I'm a Salesforce MVP and also active on the Salesforce developer community. And apart from that, I'm also a blogger at amitsalesforce.blogspot.in. And I'm just leading this Farmington developer group and Salesforce Apex series. So our agenda is that we are most of the time we used to come online and doing the session on a particular topic. So today, I don't want to take much time here, so I will try. I'm just giving this a handover to Jigar. So Jigar.
Okay. So hello everyone. Good morning to all of you who are joining from US and similar geographies. Good evening to all the people who are joining from India. I know it's late evening for you guys, and really appreciate all of you joining in here. Before we jump into the session, just a quick introduction. My name is Jigar Shah. I'm an enterprise solution architect with Eternal Solutions. I'm a speaker at a lot of community events. Most recently, I spoke at Tao Dreaming 2018, and I'm also a speaker at the other developer user groups. I'm active on the developer and trailblazer communities, and I blog at learnsfdc.jigar.wordpress.com. Jigar Shah 189 is my handle for Twitter as well as for my LinkedIn profile. Just in case we have a Q&A session planned, but just in case we run out of time and we're not able to have any queries answered, please feel free to reach out to me on any of these channels, and I'll be more than happy to assist you with your queries. Right. So taking the cue from Amit, today's session is all about big objects. And what are we going to learn about today? Here's a quick agenda for that. So today's session is mainly focused on really understanding why do we need big objects, because any new feature that we implement within Salesforce or be it any other technology, understanding the need is really very important, and that's where we thought that understanding the need for big objects is going to be really important. Moving over from that, we're going to understand a little bit about big objects and what are the relevant use cases for implementing a big object. Followed by that, we would be trying to understand what are the considerations. So let's say you've decided to use big objects, but you need to take into account certain aspects or certain pointers about using big objects, and that's what the considerations piece talks about. With all that being said, we will back it up with a demo. We'll be creating a big object right here, right now, and I'll be showing it to you. And of course, a little bit of Apex as to how we can write a little bit of Apex around those big objects. And last but not the least, we will have the Q&A session, right? Please just hold your questions up for the QA session, right? So with that, let's get started with Salesforce big objects. So like I said earlier, what exactly is the need for big objects, or why do we need big objects? Salesforce introduced big objects as a feature quite some releases back. Earlier it was a beta feature, and it has been generally available now. But really, what is the need as to why do we see big objects as a great fit in today's times? And I'll break down the answer into three basic aspects, right? The first aspect is truly about the nature of the storage. The kind of data that we store within our Salesforce instances is basically can be categorized into three basic buckets. The first being the master data. which is nothing but configurational data that each one of us store, and we typically use tools like custom settings or custom metadata types or custom labels to store that kind of configurational data. Or even sometimes, for that matter, we end up using custom objects. The next is business data. The business data is more transactional or driven, and it's more oriented towards the business. It has a direct impact on the business, so it's of essence, of significance, and very crucial. And that's one of the other types of data that we store. And the third, which is the more important one, which is in the context of big objects, is operational data. Now there is a lot of information which we end up storing within our Salesforce instances, and most of our traditional storage tools are typically either oriented towards storing master data or business data, but there is not too many options for storing operational data here within Salesforce. And when I say operational data, this could be data for the customer, or any kind of data around user behavior. Let's say I want to track user clicks, or I want to track page views. It's that what I mean by operational data. And the current storage mechanism is not really very efficient in or very friendly towards operational data, right? So this is one particular challenge that we have. Second bucket is that of performance. One of the things that I'm sure each one of us, who's been using the other traditional tools of storage, like custom objects, standard objects, or any other processing mechanisms, we see that with large data sets, when we end up writing logic, the performance kind of diminishes slowly, as large data sets come into picture. And when I refer to large data sets, what I'm truly referring to is not really hundreds and thousands of records. I'm talking about millions of records. And if you really look at enterprise customers, a lot of enterprise customers will really have that kind of data volumes, which is massive. And when you're really performing operations on that, you don't really get the scale of performance needed to operate on that kind of data sets. And you run into all kinds of challenges. Of course, there are workarounds that you do, but the thing is, you end up running into challenges. Of course, there are other things to complement it. Is there are data retrieval limits. So the maximum number of records that you could retrieve with a SOQL query is 50,000. All those limits come into play. The third and the most important and the relevant reason is we are on a cloud-based system, which means that we have limited data storage. Salesforce comes with a limited data storage, and this is one of the primary reasons which sometimes drives us towards making our databases as denormalized. I mean, we are often during the design process or the data model design process, we are often cognizant of the fact that we don't want to end up creating a data model which is trying to consume too many records. And we don't want to do that, because if our design is trying to consume a lot of records, it's going to eat up into the data storage space, and that is going to be expensive for our clients or customers. So these are the three basic challenges that we see as of today, considering there are no big objects. And let's try to understand how big objects what big objects are, and how, what is it that they have to offer, and it can help us address these particular issues. So with that, what exactly is a big object? A big object is very similar to any of your custom objects within Salesforce, but of course they are they're of a very special nature. So a big object is nothing but an object that is capable of storing massive data volumes without really affecting performance. The reason why I wanted to highlight these two aspects is because they go hand in hand. Somewhere without the big objects, we end up affecting performance. as the volumes soar, and that's exactly where big object comes in handy. Now, some of the cool features that big object offers is, it does not count against your org's data storage limits, which means that any data that you store within a big object does not really count against your data storage limits. And that's where it helps us address one of the challenges from our previous slide about what exactly is the current challenge with what exactly is the current challenge. The second is big objects really offers a massive processing scale. I mean, you can really really get great performance with with a huge amount of data. And when I say huge amount of data, it's capable of processing 1 billion records. So even even batch Apex is only capable of processing 50 million records, I believe so. But with big objects, you kind of can write Apex, and you can really do things with that kind of scale, which is really very efficient and very helpful to a lot of enterprise customers who've been out there and who have massive data volumes. Now, big objects, just like the other our regular objects, big objects come in two basic flavors. The first flavor is, there are standard big objects which are available. I'm not sure if everybody has heard of this tool. There is a tool offered by Salesforce called as Field Audit Trail, and Field Audit Trail within itself uses an object called as Field History Archive to store all the auditing information. So Field Audit Trail is nothing but an auditing tool, and it captures the data changes within the Salesforce fields. And it uses Field History Archive, which is nothing but a big object. And the second flavor is, of course, Salesforce gives you standard big objects, but it also allows or permits you to define your own big objects, which are nothing but user-defined or custom big objects. Custom or user-defined big objects are really how do you identify them? So, like regular objects or custom objects are suffixed with __c. Big objects are suffixed with __b. Right. With that, so we've understood what are the challenges that big objects addresses, but any tool or any new feature that we really implement, there is a certain sweet spot or certain use cases that it is best suited for. So with the introduction of big objects, does not mean that we end up completely replacing what we have in terms of custom objects, standard objects, or any other storage tools. We end up replacing all of those with big objects. No, that's not the right way to go about it. There are certain use cases which are best suited for big objects, and that's what we're trying to understand over here. So these use cases again can be classified into three major buckets. The first being, if you're trying to capture user activity, is what I referred to as operational data in a couple of slides ago. So when I say capture user activity, a lot of with massive data volumes being captured, customers want to capture everything within Salesforce. So they want to capture code reviews, they want to capture time entries, they want to capture page views, field audits. A lot of operational data is being captured in Salesforce now, and one of the only problems that we have right now that we had before big objects was this was all very data centric, which means that there would be huge volumes of data generated, and there would often be a need for looking at alternative storage mechanisms for this. So with big objects, this is one thing you definitely can do. The second thing is very important is when you're typically talking about a lot of enterprise customers, current or business data which is not really relevant immediately or not not really required, but is of essence from a compliance perspective. So I know for sure for certain industry verticals like healthcare or finance, there is a lot of data that needs to be historical data that needs to be stored for compliance, and that's precisely the reason why you may want to which kind of adds to your data storage, and it creates a burden. So another good use case for really using big objects is to have this historical data or data stored for compliance move to big objects, so that everything remains within Salesforce, but so you can still take the advantage of using them, referring to them uh, right from Salesforce. But of course, the benefit is it does not count against your storage limit, so it kind of frees up your org's data storage limit. And last but not the least, there is a lot of ancillary customer data that we tend to capture. So things like purchase details, transactions, which kind of fall under the bucket of business data and operational data, but it's something that may not really affect business right right now, or they're not really required right now, but you definitely want to capture, end up capturing that these particular data points. And you know big objects would make a great storage structure for capturing and tracking this kind of uh, data. So with that being said, about what are the best suited use cases. Now, when I talk about these use cases, these are not not the only use cases that we can limit big objects to. Of course, there could be tons of other use cases, but these are the most relevant ones where big objects really seems to be relevant and really helps address the problem, and that's why these are listed down. So feel free if you feel that you have a use case which really kind of fits into the big object uh, band of requirements, then it makes sense for you to really use big objects in that case, right? So with the use cases, one of the most important things that we need to do while using big objects is to take into account certain factors around how big objects work, or what is it that they have to offer, or what is it that they bring to the table. So uh, with that being said, what is it that you need to consider as solution providers? What is it that you need to consider from a big object standpoint? So uh, I have again categorized or segregated these particular considerations into uh, five major buckets. I think whenever we build any kind of application for any kind of industry vertical, I think these five buckets generally come into picture. We develop based on these five areas of consideration, and that's why I thought it'll be best to put in the features with relevance to these particular aspects. So the first is the general category, and certain things that big objects really offer, or have to offer, is big objects really are use metadata API. So you can only create big objects through metadata API. So one of the things to understand before really trying to implement or understanding a big object is you have acquaintance with metadata API. For people who are not very conversant with metadata API, metadata API is what Salesforce provides for generating any kind of metadata. So anybody who's used a force.com ID, any of the XML files that you see as a part of your force.com ID solution, those are nothing but XML files which are used by the metadata API to generate generate the metadata, right? Uh, the second very important factor is, of course, there is a limit on the number of big objects that can be stored or created within an org, and that is you can at max create 100 big objects, so you can't just translate everything that you have into big objects. Uh, one other important point to consider over here is we don't have the flexibility of using all the available field data types that we have um, with within regular standard custom objects, right? So with big objects, you can only use the listed down data types, which is date, time, lookup, number, text, and long text area. Um, which also means that if you really want to kind of store other pieces of information, you may want to be a little creative and use these field types to the best of your advantage, right? For example, if you want to end up storing an email or a phone number, probably the best thing might be to use a text. Similarly, if you want to um, you store boolean information, you could use a number field with 1 or 0 as the value. So some of these things can be really interchanged and really serve multiple purposes. It only depends on how you best leverage them. Last, one of the other important things is because big objects is designed for scale or massive data volumes, these tools for real-time data processing in terms of triggers or flows, processes, um, or Salesforce apps, they're not really available around big objects, which means that you can't write a trigger or you cannot write a flow or a process builder on a big object, which is one very important thing. Um, and of course, big objects, I'm sure you've heard of async SOCL. So async SOCL is a special type of a SOCL query. And we're going to talk about that in detail in a little bit, right? But async SOQL is not really supported uh, with all big objects instances. It's restricted to specific licenses, so you may want to keep a check for that. The next very important thing is from a user interface or a user experience standpoint. When you really create a regular standard or a custom object, you get the benefit of leveraging tabs or detail pages or list views. But with big objects, you don't get any of that. So, all you see is a big object like a regular object without any kind of data, and you've really got to um, work through as to how you can view the data which is inserted within a big object. With that being said, big objects is compliant with Visual Force pages or Lightning components, so you can actually end up building custom Visual Force pages or Lightning components for showcasing the data stored within business objects to end users, right? With big objects, you don't really get the ability of providing the finer control with record level access. So currently, big objects only supports object and field permissions. So you kind of have to live with that. When we say object and field permissions, it's only restricted by profiles and permission sets. So that's something which is available from a data access standpoint within Salesforce for big objects. Next feature is nothing but analytics, and it's a very important feature because all that data that we store in Salesforce, we want to make customers try to make some sense out of it. And one of the limitations I would say is from a big objects perspective is we don't really have the capability of having a report of a standard or a custom report built on the data stored within big objects. However, there are alternative techniques you could use uh, for really running analytics on big objects. But one of the things that greatly comes in handy, and one of the most recent or new features is Einstein analytics. So you can actually connect your big object to an Einstein analytics instance, and you could run all kind of analytics around that. Last but not the least, you definitely can package big objects. So if you are an ISV or you're building a package solution and you want to include big objects as a part of your package, yes, you can include them within your managed packages. So with that being said, for what are the considerations as to that you need to take into account for using big objects? We will. I'm so sorry. We'll move over with the demo. Now, the demo, what we're going to consider within the demo today is we're going to consider a hypothetical use case, which I'm going to walk you guys through. And once we do that, we're going to end up creating a big object right here, right now. And once we create the big object, we're going to insert a couple of records and then run some standard SOQL queries and understand how we can actually retrieve data within big objects. Async SOQL, yes, I'll be showcasing it to them, showcasing it to you guys, but the only thing here is async SOQL is not really available as a feature directly. So we may not be able to really see it in action, but I will definitely give you a demo which gives you a perspective as to how async SOQL works. With that being said, I'm going to switch over my screens back and forth now, just because I'll be, playing around with multiple screens. I'll try to be as slow as possible so that everybody follows. But if you have any questions, just hold on to them for the Q&A session, and then I can help address them. So with that, let's start with the use case as to what it. So I just really came up with this hypothetical use case. Since I'm a big fan of gaming, I thought let's try to put in something which is more gaming related, and majority of the people understand and relate to. So Extreme Gaming is a globally renowned provider of online arcade games. They have an extremely popular game which is thousands of online players, and the company is basically using Salesforce. So they're trying to store all the interactions that the players make within a single game inside of Salesforce, which means they're talking of tons and tons of data. And one other factor which really adds to that is the game has numerous interactions per day, which means that it is going to have a huge, and it being multiplied with a huge set of players, there's a lot of data that's going to get generated. So that's the use case, and what we're going to build from that use case is this seems to be a well-suited use case for really implementing big objects, just because it has a lot of data that is foreseen to be stored over here. Now, so with that being said, we've designed this custom big object, or a user-defined big object, as you see. It's called as customer interactions, and it's got a couple of fields if you see over here. These are what I've tried to do is accommodate each and every type of field, so that we get a fair sense of understanding in terms of how do you really define a big objects with each type of field, and how do you insert data within that. Now, one of the key things that you see over here, all of this looks very, very similar to your regular objects, but one of the most important things to note here is the indexes, and we'll come to that in a bit. But Salesforce, with using big objects, it allows you to define indexes for big objects, and this is typically because big objects are really oriented towards massive data volume. So indexes really give you the flexibility of defining keys which really improve your performance and really help you retrieve data efficiently without really worrying about performance. So with that being said, we're going to be looking at defining the schema. But before we define the schema, I think this slide and this particular slide would truly go hand in hand. But before I jump into really actually deploying this particular big object to the org in consideration, let me just explain to you about how you can deploy, or what is it that you need to do to deploy a big object schema definition to your Salesforce instance. So a big object schema definition typically consists of three basic files, right? There is the first file is the package.xml file, and I'll come to what it stores and what it is, the details around that in a bit. The second is the object file, and the third is a permissions file. Now, if you recall the previous slides that I had here, I mentioned that Big Objects uses metadata API, and that's exactly where we are headed towards. Is if you really see, and developers who have done some kind of deployment using metadata API, or even really opened up the XML files um, within your force.com IDs, you will see that the solutions will have a common structure, right? I mean, they will have all these three files that we're talking about. Of course, they will have a lot of other files, because they generally deal with a lot of other types like Visual Force pages and even Apex classes and all of that. But really, because we're using these files are really required because Big Objects uses metadata API, and what we're trying to do is really trying to deploy a big object with the help of a metadata API. So one of the things to note here is, if you're not really conversant with metadata API, I think it would be a great idea to get a refresher and um, get acquainted with using metadata API before you jump into you know uh, play jump into building something with big objects, right? Now, the first piece of this entire thing is the package.xml. So package.xml is really nothing but an XML file, and what I'm going to do is now I'll switch over to multiple screens. Just give me a second. Okay, is my screen visible to everyone, guys?
Yes.
Yes.
Okay. Okay. Thank you. All right. So what we have here. Okay. What we have over here is a package.xml file, and if I go back to my slide, so the package.xml file is nothing but a metadata file, and it just is a master file which tells you what is the type of metadata that you're truly trying to deploy, right? And as far as Salesforce goes, the type of metadata for a big object is nothing but a custom object. So that's where you see this particular thing where it's referred to as custom object. And the other thing that we
see your screen. I mean, we can only see the PPT, not the.
Okay. All right. Just give me a second. Let me see if I can. Okay. Can you see it now?
Yeah, now I can see it. Not bad. Yeah.
Okay. Thank you. So, so I was talking about custom objects typically. Is basically when you're using big objects, or when you're trying to deploy big objects. So basically, big objects are treated as the metadata type for a big object is nothing but a custom object, and you use them when you deploy them through a metadata API. You will need the package.xml. One other thing that you will need to include as a part of your deployment is a permission set. And if I really go back to my slide, I'm going to share my slide deck now. So we talked about the package.xml file. The second file is nothing but an object file. An object file is so I'm sorry, coming back to my package.xml file, there is something called as a permission set, and we'll come to that in a bit. But the point that I'm trying to make here is we are deploying an object and we are deploying a permission set as a part of our deployment, and that is the reason why we list all the types down, just to tell Salesforce as to what are the types of metadata that we're truly trying to deploy. Okay. For details around permission set, I'll come to that in a moment. So the second very important piece to this is the object file. And the object file is nothing but it truly stores two very important things. One being the object definition. When I say object definition, it truly revolves around, what is the name of the object, the labels, and of course the most important piece, the fields that the objects contain. And one other additional thing apart from the name, label, and fields that an object file stores is it also stores the indexes. Now, this is a very important piece when you're really defining big objects, because like I said, indexes are something which will help you form your queries, and you can only query on your index fields. So it's using a big object. So it's very, very important that those indexes are really identified during design time, right? And there is a specific order in which you specify them. The order is of essence, right? So if we go back and see, if we go back and see the object file, which is nothing but another XML file, you see that it has this kind of structure where, of course, it says, what is the deployment status. There could be two options, whether it is in development or whether it is deployed. Development generally refers to a state when you are, you're building up things and you don't really want the end users to access it, or any of your other users to access it, and that's where you might want to mark it as development. For the demo today, we'll just put it as deployed. The other things to really understand over here are the different field types. So what I've done is, and this is not different from any of your other objects. If you really open up your force.com ID and open up any of the object files that you have defined, you will see a similar structure. You will see that it has a full name, a label, because account is a lookup field that we are using, right? It's referring to the standard account object within Salesforce, and it's a required field. You can specify the relationship and the type. Similarly, if you look at the other field, which is game platform, or which has a label called platform, it's a text field of types of length 16. Again, it's a required field. And then there is another in-game purchase or play date. So play date is a date time field. You can also specify date time fields. Coming over to a different type of number. So you have, I'm getting a background noise. Can everybody please mute their mic? I'm sorry for that. Thank you so much. So you have play duration, which is again a numeric field, and you can define fields exactly in the same manner as you would end up defining fields on the regular standard or custom objects. Because when you define, and if you really see, these fields are really available even on the UI. So when you go to the schema builder, or when you really create an object through the UI, you'd see that some of these fields are available based on the type, based on the data type selected. So you have precision and scale. You want to specify if this field is required or not. So this particular part of the file is around object definition, right? So that is the first piece to your customer interaction object. And the second piece, which I talked about, of course, we have the label and the plural labels over here. But the second very important piece that I'm going to talk about is indexes. And with big objects, you need to specify indexes, because without indexes, you will not really be able to query or uh, get the or really leverage big objects to its full uh, you know hone the full power of big objects. So when you really specify an index, there are basically two things you specify. You specify the name of the field, and you specify the sort direction. So people who have been writing SOQL, there is a sort direction which you generally mention. So it could either be ascending or descending. But the only thing that you need to keep in mind with big objects is this is something that needs to be specified at the start, which means that you need to be really clear as to what is the nature of the queries, or what is the nature of information that you expect to retrieve from your big object, right? Now, another important aspect of specifying indexes over here is the order. So if you really see, there is a sort order. One is a sort direction, and of course, the other is the order of the index. And this particular order of the index is what you will see appearing as numbers in the object definition, and I'll show it to you in a while as to what exactly I mean by an order of an index, right? So with that, let's get started. Uh, okay. Uh, of course, the third most important piece around defining a big object is the permissions file. And like I said, big objects only allow you to provide permissions as to or data visibility either at an object level or a field level. So you can't really do it at a record level. And there are two main tools that you can use. You can either use a profile, or you could use a permission set to define the permissions for your big object fields or object. One thing to note and keep in mind over here is if you don't really specify any permissions, by default the access level is restricted, which means you will not be able to access the big object. Hence, it's very important that you specify a set of permissions, and we have a permissions file over here as well. I'm sorry, there is too much of switching, but there are multiple files and don't have a workaround really for it. So here we have a permission set file. So permissions, and if you look at, again, if you open up a permission set file within your IDE, it would look very, it would look similar, right? Now, what I have done is, for the ease of use, I have given readable and editable permissions for every field that we are defining in a big object, right? But in a real world scenario, you may not really want to do that. You may want to really pick and choose which of these fields are editable and which of these fields are read only. So you might want to spend some time and identify that. So we have all three artifacts for our definition ready now. And what we're going to do is now actually deploy a big object to one of my developer Salesforce instances and see if that works or not. One of the easy ways that I really use to remember what you need for a schema defining a schema for your big objects is to remember the word pop. It's pop as in POP, P for package, O for object, and P for permission. So that's a real easy way to remember what are the artifacts required for deploying your big object schema. So with that being said, I already have all of these defined over here. Okay, and what I'm going to do is log into my Salesforce instance, which I believe I already have. Okay. So one of the things, if you see over here, is you will not really find any of your big objects under your object manager or any other place. And there is a special place that has been provided to Salesforce. If you really want to manipulate or search, if you really want to look at big objects, is you can go to this quick search menu and you can look at this big objects option. And if I really click that, you see that there are no existing big objects that exist as of now on my current Salesforce instance. And what we're going to do is we're going to deploy a big object. You could use multiple tools. You could either use a workbench or you could use the force.com deploy migration tool. Workbench just really works for me, but it's not a mandate. So what you really need to do is open up your workbench. I'm just going to make sure that the session is active, and guys, I hope everybody is able to see my screen, right? Because I'm switching across multiple screens.
We are able to see that
Workbench.
So
okay,
you can directly focus on that demo, Jigar. No need to, like, if you are thinking like it's a multiple switch, no need to switch on PPT.
okay, all right. Thank you. So so what you need to do is, in order to deploy, we're going to use the deploy tool from Workbench. We're going to really go to deploy, and what this deploy tool asks for is what is the file that you're going to deploy, and there are certain parameters which you end up even setting even from your even while you do regular deployments. If you're really doing it for the first time, I'd recommend. So what we'll first do is, of course, choose a file, and because I have this particular file available already, I'm going to go and choose that. It's a zip file that we have created. So we've chosen the file. The zip file comprises of these three basic things. There's a package.xml, there is an object file within the objects folder, and permissions file within the permission sets folder. The reason why I've created these folders and put those object and permission files within those particular folders is because the metadata API structure, or um, the solution structure really requires these folders to be there as a part of your deployment. One other thing I'd really recommend is, if you're doing this for the first time, you just want to really not deploy, but to see if everything has been created properly, and if you really deploy, are things going to go through? I'd recommend that you choose this check only option, and you can choose a single package because it is a single deployment that we're doing. And we say next. So the next brings us to a wizard which just kind of shows you what are the parameters that you have set and asks you for a confirmation. And once I click deploy, what it is going to do is it's an asynchronous job, because there were very few components here. The time taken was really short, and if you see that it mentioned that it's given a success message, and it states that if you really deploy this file, everything is good, everything is going to go through. So what I'm going to do is, this was just a check, nothing has actually been deployed. So if you really go back and see to look at your Salesforce org, you'll still see that there is no big object really available. Okay, so there's no big object available. Now we'll do it one more time, but this time without the check only checkbox checked. We're only going to choose the file. Everything else is fine. We can do a single package, and then we do next. Now this time you see a different warning which says that now because you've not checked the check only checkbox, it tells you that it's going to make permanent changes to your Salesforce org, which means that if everything goes well, you should see a big object being created in Salesforce. And I'm going to hit the deploy button and wait for a while until this process completes. Okay, this is pretty quick, and hopefully we should have a big object created on our Salesforce instance. Okay, so now if you did see earlier, there was nothing available over here. We did a deployment using a metadata API, and we now have a customer interaction big object created within Salesforce. So this is how you really you create a big object within Salesforce. Now, once you create a big object, there are certain things which you can change, of course, like simple things like labels and plural labels, or for even you can even use the object name. You can change the object name, or the in development or deployed status which I was talking about. So you can do all of that, but the first time, unless you have the big object really available, all of these need to be done via the metadata API technique, which I just showcased right now. One other important thing to note over here is big objects do not come with any of the standard fields. So none of the auditing fields that are readily available on a big object are, I'm sorry, readily available on a standard or a custom object are not really available on big objects. So that is one thing you need to keep in mind. And all those fields that we defined as a part of our XML file, if you see, are now there. So all the fields, all of that, everything is there now. One of the important things to note over here is, some of the fields which we specified within the indexes section of my XML file have been marked as indexed, which means they are indexed fields. And the other very important thing to note is the position at which they had been, or the order in which they have been specified, has also been noted in addition to the index direction that we have specified. So that is how you really create a big object. Now let's go back and see as to how you can write a little bit of Apex and insert records, or what are the mediums for inserting a record within a big object. So I'm sorry, I've got to switch back to my presentation now. So I'm going to be doing that. So we've defined the schema. Now we need to insert some records. So in order to insert records within a big object, there are three basic channels that you could use. You could either use Apex to insert and manipulate records within big objects, or you could really use CSV files and upload them to big objects. Or the third technique is to use an API, and it works with bulk or SOAP API. So if you want to insert data with either a bulk API or a SOAP API, so let's say you've got an external system probably where it has some data, and that data is going to be stored within a big object, you can actually do that, and that's available. But for the demo today, we'll be, and since it's Apex hours, we're going to be focusing on how to do it through Apex, right? One of the most important things that that you need to understand from an Apex perspective is we are not really using our regular insert or database insert methods to create records for big objects. We're really using the insert immediate method, which is a part of the database class. So it's actually database.insert immediate and database.insert immediate as objects. It's just an overloaded method which has which can either take a single S object or a list of S objects, right? and you can use that to truly insert records within within your Salesforce big object. One other important thing to note over here is if you the insert operation works, or the insert or the update operation truly works in an idempotent manner, which means that they truly work like an upsert operation. So just in case if you insert a particular record, but this idempotency is driven by the index field, so which means that if you end up inserting records, or you attempt to insert records using the insert immediate method, and those records or those indexes already exist, what the behavior you will expect is it will go and update the existing particular record. But if you really have a record which you're trying to create with a different index in that particular index does not exist, it will really create a new record. So this is one behavior you've got to keep in mind while you're writing code around big objects data, or you're trying to perform or create records around big object data. So with that being said, I have a small code snippet which is written over here, which we will try to execute, right? There is some issue with other fields, and that's the reason why I have commented out, but ideally it should work for all the types that you have deployed. So what I'm going to do is I'm going to just copy this Apex snippet and explain to you what it is, and then we can run it. I'll prefer running it again through Workbench only, but of course you can go through or use a developer console, because sometimes if there are any errors, especially in terms of Apex, the console here does not give you the line numbers, so it kind of becomes slightly difficult to troubleshoot or debug, right? So with that being said, what I'm trying to really do as a part of this Apex code is I'm creating a new instance of the big object, right? And if you see, it's __b and not __c. The technique of creating an instance is still the same, right?
Sorry to stop you.
Yeah.
You are still on PPT or sharing your code?
I'm sharing my code.
We are able to see this your PPT only.
Okay, sorry about that.
No problem. That's fine.
Let me know if you are able to see it now.
Yeah, we are able to see your screen now. So previously, I was thinking like you are sharing the code, but only PPT was visible, so that's why I stopped it. Now we are able to see your Workbench screen. Thank you.
Okay. So I'm going to repeat that for people who just missed out. So I have this piece of Apex code ready, and what this Apex code snippet simply does is it inserts a simple record within a big object. I am using the Apex execute console from the Workbench, though it's not a mandate. You could end up using your developer console. The execute anonymous block and works just fine. One of the advantages you get there versus this particular screen is you get line numbers and you get a truly functional editor. So if you are one of those persons who really doesn't remember the syntax, and somebody like me, probably you might want to end up using the developer console. But just because I have this particular code ready, I'm going to take the liberty of, and I have Workbench open, I'm going to take the liberty of running it through a Workbench. So just to walk you guys through the code snippet, this line here, it creates a new instance of the customer interaction big object, right? And if you see that the technique is very similar to instantiating any kind of object within Salesforce. So even if you're doing a regular account, or if it's a custom object, the technique remains the same. The only thing to note here is it's __b and not __c as in custom objects. Once you do that, you end up specifying all the fields that you want to specify values for. I've been having challenges with some of these fields, and that's the reason why I have commented it out. But on a whole, as per the documentation, it should work. So that's how it is. And last but not the least, the database insert immediate method that I was talking about, it just inserts a record synchronously within your Salesforce big object. So what this code snippet is actually going to do is just create one record of type customer interaction within your Salesforce interaction, within your Salesforce big object. So with that being said, what I'm going to do is I'm going to say execute, and let's see if this creates a record. Don't really worry about the ID. I know this particular ID exists in my Salesforce instance, and that's the reason why I have hard coded it. As a best practice, please do not hard code IDs. If you see, everything went fine, and the execution completed, and we have one particular record that should be created. We'll see that in a bit when we get to standard SOQL as to how you query and see the records. One of the drawbacks of using big objects is you really don't have a mechanism where you can, unless you really write a SOQL query, you can't really end up seeing the records that are created within your big objects. Okay. So I'm going to insert a couple of more records just to make sure that so that we can get a decent amount of okay, and say PS4 4. So it's basically the same code that I'm truly running. I'm just trying to have unique values for this particular platform index, and this is PC. So we're trying to create interactions from 4 different types of gaming platforms: Xbox, PS4, PC, and PS2. So now if you see, all of them went through, and the Apex code worked, and the records have been created. This is just for demo purposes. And for simplicity, I've been using a single record. You can actually, write a for loop and create a list of customer interaction type and insert that also, and it should work fine, right? Okay, so that is how you actually run Apex on your big objects and create records within big objects. Now, once we have created the records, we also want to see what records have been really created, and that's exactly where I'm going to talk a little bit about standard SOQL first, and then we will quickly come back to our query editor and then run a few SOQL queries to visualize what all data we can really have, we have really inserted within our big object. So I'm going to switch back to my slide deck. If you guys are not able to see it, just let me know. Hopefully everybody should be able to see that. So standard SOQL is nothing very different from your regular SOQL that you are writing on objects other than big objects or objects which are not big objects, right? Except that there is certain special behavior which you need to account for when you're writing standard SOQL with big objects. I'll just try to, of course, there's a ton of information in the documentation. I've just tried to highlight the most important ones. The first and foremost thing is standard SOQL is really, it executes in a synchronous mode, which means that as soon as you request for the results, you got to wait until the results are processed, and you get back the response immediately. So that's what you mean by synchronous processing. It's pretty much the same way that your regular SQL would process or behave. The second very important thing or aspect to consider is all indexes which you have specified within your file, which I'm going to switch back again. So if you see that there is this particular indexes section, and there are 3 particular fields which you have specified. So if you have specified those 3 fields, it is important to include each of these index fields uh, within your standard SOQL query. If you don't really, you miss out on including any one of the index fields within your SOQL query, your SOQL query will not work, and it gives you an error, right? And we'll replicate that, and I'll show that to you. But this is one very important feature or behavior that kind of differentiates your regular SOQL processing with non-big objects as compared to using SOQL with big objects. The other thing to note over here is uh, there are certain comparison operators which are supported, and which are the regular ones, of course, equal to, no, greater than, less than equal to, greater than equal to, and the in operator. These are the operators which are supported when you are using standard SOQL with big objects, and there are operators like, not in, not equal to, excludes, includes. So those operators are not supported. So you may really want to consider what is the nature of your queries, or what is the data that you're trying to retrieve with your big objects, from your big objects. Accordingly specify your index fields, and based on that, because that is also going to drive how you will be able to write your queries. Okay, so with that being said, let's just run a few queries that we already have and see if, as to how data how data can be retrieved from a particular big object. So I have switched back to my editor, where I have some of the queries which are already listed, and what I'm going to do is copy these queries and just run them over here. I hope everybody is able to see my workbench screen. If anybody is not, just let me know. Okay.
Yeah, we are on your notepad screen.
Okay, you're on that screen. I think you should be able to see the workbench screen now.
Yep, we are able to see.
Okay, awesome. So what I'm really using is this SOQL query option from provided by Workbench. And if you go and see over here, you should be able to see our customer interaction object, which is already there. I'm going to select that. And since I have the queries already listed, I'm not really going to go over to this wizard, but instead paste the query over here and just try to run and see if that kind of gives me the desired result. One of, like I mentioned, one of the important things to note here is all the index fields that we had specified in our object definition file. All of those index fields have been included. If you really don't include those fields, the query will not run and it will give you an error. This is actually uh, Salesforce's way of mandating developers to write good selective queries and write queries which are using index fields, and that's why probably this mandate. So what I'm going to do is I'm going to try and query the records, and if you see that I'm able to see the record. So we inserted a couple of records. We inserted one record for Xbox, one for PS2, PS4, and PC. And because I just queried Xbox, this is one of the queries which has run, and these are the results that we see over here. Now let's see what happens if I just remove this particular field over here, which is an index field, and I try to run this particular query. Okay, so it says filters may not have any gaps within the composite key, which means that what it's trying to say is you have certain index fields defined on your big object, but you've not really used them. So what we're going to do is we're going to put those index fields back, and I'm going to run the query once again, and it should work now. Okay. So this was one of the simple queries. Let's say if I want to query multiple records, I've just kind of, added queries with different criteria over here. I'm going to take this particular thing here. Okay. I'm going to key in a new query over here. I'm going to run it again. Yeah. So, sorry, that's PS4 and not, that's the reason why it did not match and really give you the record. Yeah, so now you see that there are all the records which are there. So this is one other technique which you could use to retrieve multiple records within your from your big objects. For demo purposes, I've only really restricted that result set to like very few five records. But really, when we're talking about big objects, it's massive number of records, and you could run queries around that. So this is about standard SOQL, but and we'll of course come to this discussion as to when you should really consider SOQL versus async SOQL. But one of the other features that that you can use with big objects is async SOQL. And let's see what really async SOQL is and what it does. So I'm going to switch back again to my presentation here, and give me a minute. Okay. So I'm back on my presentation, and you should be able to see that. So an async SOQL is typically nothing but a SOQL that is executed in an asynchronous fashion via a REST API. That's how Salesforce has implemented it. And what you really do as from an async SOQL standpoint is you really specify 4 important parameters within your async SOQL. And those are the query as to what is the SOQL query that you need to use to retrieve the data. What is and the second is nothing but the operation. An operation is nothing but whether it is going to be an insert operation or an upsert operation. And the third is there is a target field map and a target value map. Now I'll come and explain as to why target field map or target value map is truly required. Async SOQL is truly designed for massive data volumes versus standard SOQL. When you're using standard SOQL with big objects, you really want to use that when there is less number of records that you want to process, right? And that brings me to this particular slide of consideration as to why when you should use a standard SOQL versus when you should use a async SOQL. Standard SOQL executes in a synchronous fashion, whereas async SOQL really executes in an asynchronous fashion, which means that if you have a requirement for an immediate response time and the data sets are truly smaller, you might want to end up using standard SOQL. But if you really that it is a background operation with massive sets of data, and again, when I say massive sets of data, it's millions of records that we're trying to process. You definitely want to consider async SOQL. Now, one of the other things that you have is async SOQL is a subset of your standard SOQL, which means it uses a lot of clauses and uh, uh, features from the standard sockle, but it's not all the features. So you can actually look at async sockle as a very specialized sockle framework, truly designed for processing heavy data volumes, right? Uh, a standard of sockle would best be suited if you're like, if you're really trying to showcase some data, retrieve some data from big objects, and trying to show it on the user interface, or you're trying to manipulate or process some records within Apex, and you need the data. Standard sockle would be a good choice to for that. If you really have needs for aggregation on millions of records, and you want to summarize the data which you have for further analytics, async sockle is a much better option and gives you the right kind of throughput as compared to a standard sockle in such cases. If you want to filter using non-index fields, you can definitely give async sockle a shot. And last but not the least, one of the key factors or key differentiating factors is the syntax. So if you see your regular sockle, this is the syntax, and that's the same for when you end up using sockle with big objects. But if you really use async sockle, it's actually a JSON structure that you create, and I'll show you as to how and what is the structure that you create. But this is the typical structure. So the reason why I was explaining this particular part as to from an async sockle standpoint is about aggregation and summarizing is because there are two other important parameters which you really need to specify mappings for. So typically async sockle is used when you want to manage your massive data set. You want to tone it down, summarize it, aggregate it, and then use it for further analytics. And that's the reason why you have these particular key value pairs over here. I don't know if this is very visible, so I'm going to switch back to my code editor where it hopefully should be a little more visible. All right. Switch back to my editor, hoping everybody is able to see the code editor now. What I have is a sample async sockle request that I have created, and in addition to query and operation and the target object. So basically, first thing that you specify is the query. So what is the sockle query that you want to use to filter out or aggregate your data? In my case here, it's a very simple query, but you can use all your aggregation operations like average, min, max, sum, count within the query over here. Additionally, you'll need to specify what kind of an operation it is, if it's an insert operation, okay, or if it's an update operation. And I know it's a little bit confusing when when you're trying to say that you're actually trying to query and retrieve records. Why do you need to state this operation? And I'll explain that to you in a bit, because when you're truly doing async SOQL, you are trying to fine tune, not really fine tune, but summarize your data and actually dump it into a different object, so that the data is more manageable and you can use it for for analysis, or it's truly concise data. So imagine you've got millions of records, you kind of aggregate them down into summarized set of records which are now a few hundreds of records, and you just put them down into another object, which is nothing but a target object specified over here. Now this target object could be anything. It could be a custom object, it could be a standard object, it could be an external object, or it could be another big object. You can really, you literally have the liberty to do that. There are two other things. Because you're specifying an object, you will also need to specify the field mappings over here. So there is this piece over here truly specifies what field in your source maps to what field in your target. Similarly, so what I have is we have accounts __ C and in-game purchase as the fields on our customer interactions big object. What I have done is I have a customer interaction analysis big object, which is nothing but a summary object, which is going to be used for analysis of how the customers interact with the game. And it's truly going to be, some kind of analysis information. I have these fields also existing on the customer interaction analysis object, which is account __ C and purchase __ C. These fields have already been created, and this is nothing but a regular custom object. So this particular section tells you which fields need to be mapped from the source to target. And last but not the least, sometimes as a part of, or most of the time when you kind of do an operation where you're trying to load data from one entity into another, you want to include some static content or background information, and that's exactly what this particular section is doing. The target value map helps you map static literal strings to fields on your target object. Now, copy fields from source to target is actually a static literal string. So if you actually run this and the records are copied over, this particular field background operation description __ C will actually have the data value copy fields from source to target. But this particular key over here, and $job _ID is a reserved key, and it really refers to the job ID of your async job. Now, like I mentioned, async circle really executes as a job, which means that once you make a REST request, the job makes a request to the endpoint REST URL, right? And if everything is fine, it gives you back a job ID, which will look something like this. I'm going to just copy that over so that it's visible to all of you and you really don't have to switch back and forth. So if you really see that, if I really run this request, I'm going to get a response which looks like this. And one thing to note over here is the job ID. The job ID is what helps you, query or check the status of the job, because this job is run asynchronously. It may take a few minutes, to complete the job, but with the help of the job ID, you can really use that to identify the status. One other thing it gives you is, of course, the query that you had, which was running, the status. So just like your batch jobs, there are multiple status values that also apply to your async circle job. It could be either new or it could be cancelled. Cancelled status occurs if you've run the job and you felt that something is wrong and I just want to abort it or cancel it out. In that case, the status would then be cancelled. There is an error status, and there are a couple of others, and success, which definitely means that everything went through and the job ran successfully. And it also gives you back the target object, the field mapping, and the value mapping that you have specified. So this is a response that is generally available once you make a request to your big objects using async circle. So what we're going to do is I'm going to try and run this, although this will not run because the async circle feature is not available on the, or not activated on my developer edition, but you will at least get to make sense of what I was talking just a few minutes ago. So what I'm going to do is I'm going to take this and I'm going to go back to my workbench. Okay, let me know if you guys are able to see the workbench now.
Yeah, we are able to see your workbench.
Okay, So there are two ways actually in which you can run an async socle. One is you really have this.
Sorry to interrupt you, Jiten. I just want to note you, like, this meeting will be hand soon, so try to wrap up as soon as possible. We can do that.
Sure, we're almost at the end of it. I think this is the last section which we are really going through. So we'll be done probably in the next 5 or 7 minutes.
Yeah, thank you.
Okay. Okay. So coming back to async socle is if you want to run async socle and you want to do that through the workbench, you've got two options. You can see this async socle query option over here in the workbench, or because I said that async socle executes as a REST API call, you can even use the REST Explorer. What I'm going to do is I'm going to try to show it to you both ways. I know that we'll not get the output, but at least you get a sense of how it runs. So let's try it through the REST Explorer first. So in order to run it through the REST Explorer, you got to really understand a little bit of REST concepts here. I'm not really going to cover the REST concepts over here, assuming that you have a little bit of acquaintance as to how you make a REST service call. But one of the things to note is when you make an async call, it's typically a post call, right? And the endpoint that you will be using for the REST call is async queries, right? So this part pretty much remains standard, but this is what is of essence and of importance. And what I'm going to do is I'm going to copy the sample post body that I have over here. Okay, and I'm going to specify it. So it's nothing but the sample JSON body, which I have specified over here. And once I try to execute, okay, it did not run because the functionality is not enabled. One of the things you need to account for when you're using big objects is async socle is not readily available on all orgs, and you need to let Salesforce know, and you need to request them for an activation for really using async socle. The second technique of running the same thing is, if you're not really very acquainted with using the REST Explorer, probably you want to just switch back to the async socle query editor. This gives you two basic screens, one to define your query, and it works in an extremely similar fashion like you would do for your regular socle. So the source object that we're really trying to look at is customer interactions, and then what you can do is you can choose the fields. Because I have the query already listed, what I'm going to do is I'm just going to copy the query and paste it here, and this should bring me to the next mapping screen. So all we are just trying to do is whatever we did through JSON within the REST API call, we're just doing the same thing, but now you just have a sophisticated interface. So whatever is your comfort level, based on that you can really use whichever option works best for you. So here you see that there is an insert and upsert operation which we're talking about, and if you see the JSON screen, you'll also see that the operation key has a value called insert. Switching back to my workbench, there is a target object which you will need to specify, and you are doing that in your JSON as well. So I'm going to specify my target object. I'm going to specify what are my field mappings. So account maps to account and purchase. And of course, the value mapping piece where you're going to specify your literals. Of course, it's optional. I'm not going to specify that for now, just in the interest of time. And we do a submit. We should get the same result, which means that the functionality is not enabled, and that's the reason why you cannot run an async socle. But switching back to my code editor, the response you would receive is typically would be something like this, which is over here, and this job ID which you get is something which is very important. You can use that job ID to understand or know the status of your job. So if you're really having some kind of UI, or where you want to check the status and inform the user, you can really maintain this job ID somewhere and then use that to get the status back by making a REST call. In order to get the status back, this is the REST endpoint that you will have to use. The first part of it pretty much remains the same. The only thing you will need to add is the job ID. So what I have specified over here is a placeholder, but in actual uh, cases, what you're going to do is the REST query is something going to be like this. One important thing to note is here we're trying to retrieve information, and that's the reason why it's a get call versus this, which was a post call, because we're trying to post information to Salesforce. And we talked about canceling a job. You can also cancel the same thing, use the same endpoint. The only option that you may want to use is the delete option. If you want to really understand what I'm talking about, right? Get, put, post, patch, and delete. You just go back to your workbench and you go to the REST Explorer. And if you really see, these are the 5 options that I was talking about. So, if you want to cancel a job, use the delete option. If you want to start a async sockle job, you want to use the post option. You want to retrieve the status, you want to use the get option. Okay, and switching back to my screen now. With that, that brings us to the end of the session. The considerations of sockle and async sockle we've already covered. For smaller processing, it's better to use standard sockle versus for heavy data volumes, it's best to use async sockle. The nitty-gritties I've already covered. And if you feel you want to dwell further into big objects, even after the session, and you find it interesting enough, there is a ton of information. Some of these I could list down. One of this is, of course, there's a trailer module on big objects, which helps you understand the basics. A lot of the code snippets that I have been using are also available there, but I will also be sharing the code snippets that I have here. In addition to that, there's a great YouTube video on how you can actually bring big data to force.com around big objects, which is a Dreamforce session. And last but not the least, you have the Salesforce documentation, which is the big objects implementation guide, which is an exhaustive reference, which you can definitely use if you want to just start scratching the surface. Probably you want to just proceed in the order that I mentioned. That should give you a good hold around how you can use big objects. And with that being said, that brings us to the last slide. If we have any questions, I don't know if we have any time left for that, Amit, but if we have, we can definitely take up questions. If not, you can just reach out to me.
Couple of questions are in chat. Couple of questions are in chat. So if you can quickly pick up the question from the chat window and try to answer, that will be great.
Okay.
I know, guys, there are lots of questions there, but we are already running short, so we will trying to wrap up this as soon as possible. And whatever question we can answer right now, we will do. And after that, I will try to post the PPT and video somewhere on my blog, and you guys can post your question there. Me and Jigar will try to answer all of your query. That's for sure.
Sure.
So quickly,
so I'm going to really
pick up the question from the chat and try to answer them.
Yeah, so there is this query by probably Anurag, which says that as far as I know, they will need to move one to through async sockle, but this feature is currently in pilot mode. It is now available. It's only that you will need to request Salesforce to activate it for your Salesforce org. By default, async sockle is not available. So just in case you need that, you will probably have to raise a case with Salesforce. I have not really tried doing that, but that is something which what the documentation also states, and that's something which we will need to do. The second question is, what is the limitation of big objects to store archive data until what size it can be extended? Okay, so typically they mention that 1 billion is what you can store, but they don't really have the documentation does not clearly state any kind of real number. Although from a storage capacities perspective, it doesn't really count against your data storage space, so you don't really need to be worried about it. But yes, I mean, to keep it short and simple, 1 billion is a number that they specify that you can store and process, but that's not something which they've stated in black and white. So again, I mean, you got to check back.
Yeah, actually, if we look into the org, it shows just 1 million as a limit there. That many records we can store in big objects. So, like if we plan to have an archive solution from the large objects from regular storage area to move into big objects, like what will be the limitation? That's what I'm trying to understand.
Yeah. So one of the things is, of course, you will, the storage capacity, because at some point in time, you will end up, being limited by the number, though they don't clearly specify the number. So, and I don't think it should be 1 million. It should probably be 1 billion, because that's the scale that, big objects are really defined for. But I can definitely check that once again. But that is typically one thing. Second thing is, if you're really looking at it from an archival perspective and really looking at archiving files, I don't know if big objects will really fit the bill, because you don't really have
no, not for archive files, but archiving the data. Like when in our actual storage of Salesforce data grows, then we get to the limit of storage limit, right? And if you want to reduce the footprint on that storage, if we can get that onto our big objects and store it for basically longer duration, right? Just as archive.
Sure.
Even though it is not required to be accessed online.
Yeah. So
in that case.
Yeah, I mean, you definitely can do that, and that's exactly why big objects are made up for. So when you say limits, you virtually will have whatever limits they specify in terms of the total number of records that can be stored. But that's what I'm trying to say. It's 1 billion, but I don't think I've seen anything in the documentation which really kind of states this number in black and white. And the other thing you may want to consider is field types, because your transactional types would be of various different types. So you may want to really consider what are the different field types, and if they can really be accommodated into an equivalent field type of a big object. Yeah, if not, then probably you may have to have some kind of layer written which when you archive kind of makes the data, the transactional data more compliant for archival, so that you can actually put it into a big object.
Okay. Yeah, we'll explore more on that. Thanks, Jigar.
Yeah.
Yeah, thank you so much, Jigar, for this session, and this is really helpful and informative. And thank you so much for the demo. And I also want to thank everyone. Like, there are a couple of groups which join us this time. Like there are a couple of groups. So let me take which all group are join us today. So that's first of all Farmington Hill, and apart from the Miami group and Chicago group join us from the US, and apart from that there are 4 group also join us from the India: Chandigarh group, Mumbai group, Ghaziabad group, and Hyderabad group. So thank you so much everyone and to joining us. So next time we will again come back. So we also have another session on next Saturday, that is on the Lightning component update in Spring 18. So let's see you in next week. Thank you, everyone.
Thank you so much. Thank you, guys. Really appreciate you guys joining in. Hope this session was helpful. Just feel free to reach out to me after this particular session if you have any queries. All right. Thank you so much.
Thank you so much. Bye-bye.
Bye.
Thank you.
Thank you.